Hi guys, this video is going to cover 9-1, which is circles and parabolas. Here's your frame game for today. I'll let you take your guesses and then maybe I'll share at the end of the video. Alright, so chapter 9, section 1 is circles and parabolas. As we enter into chapter 9, we're going to talk a lot about conics or circles, parabolas, ellipses, hyperbolas, all that stuff. So we start with, what are these? A conic or a conic section is the intersection of the plane and a double napped cone. So the double napped cone is like an hourglass, which is this shape here, right? This whole shape is called a double napped cone. When you slide a plane at different points, it creates these different shapes or different conics. So the first one we look at is our plane that's slid horizontally through the cone, either the top or the bottom cone, and it creates a circle. If you slide the plane in kind of at a diagonal, but still go through both sides, you create an oval or an ellipse. If you slide it through, like partially through the side and partially through the top, it could have been there, it could have been down here as well. Then you get this shape, which we know is a parabola. And if we slide in vertically, you get this shape here, which is a hyperbola, which is basically two parabolas turned away from each other, which can be vertical or they can be horizontal. So eventually, by the time we get to 9-3, we'll have learned about all four of these. But today we're going to focus on just the circle and the parabola. All right, so a circle is the collection of all points, x and y, that are equidistant from a fixed point, HK. That fixed point is called your center. HK is called the center. Okay. And if you remember, we've talked about this, but it's been a while since we talked about the standard equation of a circle, but it is x minus h squared plus y minus k squared equals r squared, where the HK is the center and the r is the radius. So when you see something like x minus 3 squared plus y plus 2 squared equals 16, I change the sign here and here, so the center would be 3, negative 2. And the radius, I'm going to square root. And we can take information out of the equation, put it back into the equation, and also find the equation. In a little bit, we'll talk about how to do that. Okay, example 1 says the point 1, 4 is on a circle whose center is at negative 2, negative 3, as shown in the figure. Write the standard form of the equation of the circle. So in order to write the standard form, we need x minus h squared plus y minus k squared equals r squared. So we need a center and the radius or a point on that circle. So there's two ways to do this. One, we already have, well, for both of them, we already have the center. So that's the first thing I already have, HK is negative 2, negative 3. So that part I know. But then the radius can be found two different ways. One is actually showing the distance between these 2 points. So for that, I can use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And I would just make sure that I put the x's and the y's. So this could be 1 and 1, and this could be 2 and 2. And it doesn't matter which numbers are which, as long as the pairs stay together. So let's say x2, which is 1 minus a negative 2 squared plus y2, which is 4 minus a negative 3. And I get 3 squared plus 7 squared, or 9 plus 49, which is the square root of 58. So that's the actual radius. When we plug it back in, we square it. So I don't need to simplify this, because if I plug it back in, I get x, I'm going to use my center, plus 2 squared plus y plus 3 squared equals my radius squared, which is 58. That's one way to do it. The other way to do it is to take my 2 points. So if I have 2 points of a circle, I can just take those 2 points and plug them in to the equation, as long as one of those points is the center. This time it matters what we make these. So if I'm going to do it that way, then my center has to be the HK. And then the other point, or the point on the circle, would be my XY. And then I'll plug it into this. So I'd get 1 minus h, which is minus a negative 2, plus 2 squared, plus y, which is 4, minus a negative 3 becomes plus 3 squared, equals r squared. 3 squared plus 7 squared equals r squared, and 9 plus 49 equals r squared, which means r squared is 58. If it wanted the r, if it had asked for the r and then the equation, then I would have to square root 58. But because this wants the equation, I can simply go from there to here, because r squared is what goes in here. My h would go here, my k would go here. So it does not matter which of those ways you choose to do it. Just do whatever seems the most easiest to you. All right, example 2, putting an equation into standard form. Sketch the circle given by the equation and identify its center and radius. Now this equation is not in standard form, and I know that because I have an x squared and an x, and I have a y squared and a y. So as soon as you see the x and the x squared, or the y and the y squared, doesn't have to be both like this one. This, we're going to have to complete the square. And we're going to have to do it twice. Once for the x and once for the y. So I'm going to group the x's together first. I'm going to leave that space because I'm going to fill it. I'm going to group the y's. I'm going to leave that space because I'm going to fill it. And I'm going to bump the 6 to the other side. Now remember, complete the square. We take the second term, divide it by 2, and then square it. So 6 divided by 2 is 3, and 3 squared is 9. And that's what we add inside the parentheses. And because we're trying to keep this in standard form, we're going to do the same thing to the other side, which is add it over here. So whatever you add here has to also get added here. For y, I would get negative 2. Remember, the sign doesn't matter because we're going to end up squaring it. So 2 divided by 2 is 1, and 1 squared is 1. So that's what I'm going to add here and also here. So I'm going to rewrite this as x squared minus 6x plus 9 plus y squared minus 2y plus 1 equals negative 6 plus 9, which is 3, plus 1, which is 4. Now I put it into perfect squares. The last thing I need to do is factor these. So again, when we factor, we're going to square root the first term. We're going to square root the last term. And we're going to take the sign from the middle, put it in the parentheses, and square it. So if I do that for the x's, square root x squared is x. Square root 9 is 3. Sign from the middle is negative. Put it in the parentheses, square it. Repeat it again with the y. Square root of y squared is y. Square root of 1 is 1. Sign from the middle is negative. Square it. And there's my equation in standard form. Then I go back to the question, which actually said sketch the circle given by the equation and identify its center and radius. So from this equation, my center is 3, 1, and my radius is 2. Okay, so I brought my coordinate grid in so that I can graph this. My center's at 3, 1, which is here, and my radius is 2. So to the right, I'm going to go 2 points, up 2 points, left 2 points, and down 2 points. And then connect them as best you can with your circle. And there's the graph of that equation. All right, example 3 says find the x and y intercepts. So again, we're going way back on this one, but remember that to find x and y intercepts, it's the same no matter what kind of equation you have. To find the x-intercepts, you're going to plug 0 in for y and then solve for the x. And to find the y-intercepts, you're going to plug 0 in for x and find the results for y. So let's start with x. Plug 0 in for y, x-intercepts. This would be negative, equals plus negative 2 squared. Subtract the 4. So what you could have done is expand and foiled x minus 4 squared. But then there's situations where it might not be factorable and you'll have to use the quadratic equation, which is why I'm going to do the even root property this time, which is get that squared on the side by itself. And then I'm going to square root both sides. But when I do, I have to remember to do plus and minus on the right. So this becomes x minus 4 equals plus and minus the square root of 12. I can simplify it there, or I can wait because at some point I'm going to have to simplify it anyways. 12 would be 4 and 3, which becomes 2 root 3. And then the last thing I want to do to get that x by itself is add the 4. So x equals 4 plus and minus 2 root 3, which means there's two x-intercepts, one at 4 plus 2 root 3, and one at 4 minus 2 root 3. Now, if I was using these to graph the circle, then I would have kept it as square root 12. I would have done 4 plus square root 12 and 4 minus square root 12 and approximated root 12. So I know root 12 is in between root 9 and root 16. A little bit closer to 16, but not by much. So we can have said that this is 4 plus 3.6 and 4 minus 3.6. And so our two approximated points would be 7, 6, and 0.4. I would use that to help me graph them. This time it's not asking to graph. It's just asking for the intercept. So here's my first two, and I'm going to keep those exact. So these, again, were the x-intercepts. Now I'm going to repeat that whole process for the y-intercepts. So I plug 0 in for x. And I get negative 4 squared plus y minus 2 squared equals 16. Subtract the 16. Square root both sides. Normally I put a plus and minus there, but plus and minus 0 doesn't matter. It's still 0. And then add the 2. So there's only one y-intercept. So an easy way to check these is because we can quickly find the center here, 4, 2, and the radius 4. We can check these. Again, it won't be exact, but we can go 4, 1, 2, 3, 4, 1, 2, and then we can go left 4, right 4. That is really not exact, but you get the idea. So look, here's our y-intercept at 0, 2, and we said that our x-intercepts would have been at 7.6 and 0.4. This appears to be about 0.4. 5, 6, this is the part that got a little bit off, but that's pretty close to 7.6. So it's an easy way to check it if you had the extra time. Okay, now we're going to talk about parabolas. So a parabola, which we've, again, covered a lot this year, but this is in a completely different way. These are not quadratic formulas, that kind of stuff, where we're finding the intercepts and the max and the min. This is a little bit different. We're going to find a parabola, which is the set of all points x, y in a plane that are equidistant from a fixed line called the directrix. So we bring in something called a directrix, which you should have heard of in Algebra 2, in Algebra 2 Honors, but let's pretend you've never heard it before. This is a line that's a fixed distance away from my vertex, and from my curve, sorry. And then there's something called a focus, which is inside the curve, and the focus is just a point. So a fixed point is called the focus. A fixed line is the directrix. So when you're graphing these, notice that your parabola will always curve around the focus and point away from the directrix. Sometimes, let's say my parabola is turned on its side, the focus would be inside and the directrix would be behind it. If it was pointing to the left, if my parabola is pointing to the left, then my directrix is going to be to the right. The focus is still inside the curve. And if it was pointing down, then the directrix would be above it and the focus would still be inside the curve. The midpoint between the focus and the directrix is the vertex, which means if I know any two of these three, I can find the other one, because the distance here is the same as the distance here. So sometimes they'll give you the vertex and the focus. You'll count that distance and you'll do the same distance away in the other direction for the directrix. Sometimes they'll give you the vertex and the directrix, and again, you'd count that difference and move the same distance away from the focus. Sometimes they give you the focus and the directrix, and you'd have to find the point in the middle, which would be the vertex. And lastly, on this graph is the axis of symmetry. So this is something we also have already talked about. The axis runs through the vertex of the parabola, and it's going to be perpendicular to the directrix. On the one I've drawn in the bottom here, that would be my axis. All right, standard equation of a parabola. The standard form of the equation of the parabola with the vertex hk is as follows. So notice that these are different from our standard or our quadratic form. This has x minus h equals 4p times y minus k, and p can't be 0. We'll get back to p in a minute. And y minus k squared equals 4p x minus h. For the x squared, it's a vertical parabola. So you're pointing up or you're pointing down. And these are the ones that we've worked with a lot this year. When the y is squared, this is a horizontal parabola. And you're pointing left or you're pointing right. The x squared one, the 4p would be positive if it points up and negative if it points down. And the y parabola, it would be negative 4p if it points left, positive 4p if it points right. The focus lies on the axis p units away from the vertex. So we just talked about that. The difference is here that we would take the number that is next to this and set it that divided by 4 is the number of units from the focus to the vertex or the focus to the directrix. We'll look at that in a minute, though. And then the next one says if the vertex lies at 0, 0. So if I don't have anything with the x or anything with the y, then my equation simply looks like this. X squared equals 4p times y. And y for this would be for the vertical. And x squared equals 4p x. I'm sorry, y squared equals 4px for the left and right. So this is if hk is 0, 0, it would simply just get eliminated from my parentheses. Okay, so here's some more information about my parabolas. If they're vertical, so this would be if they're vertical and there's an hk, this would be x minus h squared equals 4py minus k, look like this, right? If that 4p is positive, it's going to look like this. And if that 4p is negative, it's going to look like this. I've got a vertex. I've got my parabola pointing up. The distance between the parabola and the focus is going to be p. And the distance between the vertex and the directrix will also be the value of p. If that 4p is negative, now it's pointing down. Okay, distance is still p here and here. And if it's horizontal, now we've got the y minus k squared equals 4p x minus h. If the 4p is positive It's going to point to the right. Here's my vertex. Distance between the vertex and the focus is still P, and distance between the vertex and the directrix is still P. If the 4P was negative, now it points left. Focus still is inside, P distance away from the vertex, and directrix is to the right, P distance away from the vertex. Okay, so example 4 says, find the standard form of the equation of the parabola with vertex at the origin and focus at 0, 4. For me, I need the visual. You may not need it. You might see that the change here is happening on the y, and that makes sense to you. But for me, I tend to always graph it. So I'm going to take what they give me, which is the vertex is at 0, 0. And the focus is at 0, 4. 1, 2, 3, 4. So remember that the curve goes around the focus, which means this parabola is pointing up, which makes it an x squared with a positive 4p. So that I already know. Now I need my vertex, which is at 0, 0. And I know what p is. P is the same units away from the vertex. 1, 2, 3, 4. So p is 4. Just with that information, I can take and plug it in. So if you remember x minus h squared equals 4py minus k, you can just memorize that one. And then if the center or the vertex is at 0, 0, you would know this is 0 and 0 instead of having to memorize two equations. So I'd get x minus 0 squared equals 4 times, it's a positive p because it's pointing up, 4 y minus 0. And then I'd get x squared equals 16y. Looking at B, it says the vertex at the origin and the focus at 1, 0. So again, I like to draw it out. Vertex at the origin means 0, 0. Focus at 1, 0 this time. Curves around it. Vertex, which means this is a y squared with a positive 4p. So y squared because it's right or left, positive 4p because it's pointing to the right. So my vertex is again at 0, 0, and the p this time is only 1. So because it's y squared, it's y minus k squared equals 4px minus h. The k is 0. The p is positive 1, and the x minus h is also 0. And I'd get y squared equals 4x. Okay, now I know C is not on your original notes, but I want you to add it on. If you opened the original notes, they wouldn't be there. If you open the new notes, it will be, but not the original. Because we want to look at the directrix too. So vertex at the origin, directrix at y equals 2. This is going to be vertex at the origin again, which is 0, 0. Directrix at y equals 2. Remember, if it's a y equals, it's a horizontal line. If it's an x equals, it's a vertical line, which means this is the directrix. Now, we said that the parabola points away from the directrix, which means it's going to point in this direction. That tells me immediately it's an x squared with a negative 4p or a negative p. So to get the value of p, I'm going to count from directrix to the parabola, and that's 2. So I get x minus h squared equals 4py minus k. X, the origin, means that this is 0. It's a negative 2 because we said it's pointing down. And the k is also 0. And there's my equation. X squared equals negative 8y. Okay, example 5 says find the standard form of the equation of the parabola with vertex 1, 3 and focus 1, 5. Again, I need the visual. So I'm going to draw vertex at 1, 3 and focus at 1, 5. So this is my vertex, this is my focus. That means that my curve is going to curve around the focus, which tells me that this is an x squared parabola and it has a positive p, which we can count right here, 1, 2. This time, my vertex, my HK is 1, 3. My P is a positive 2. So I'd get x minus h squared equals 4py minus k. X minus 1 squared equals 4, positive 2, y minus 3. X minus 1 squared equals 8y minus 3. And there's my equation. Now, what would have changed, let's say if my focus was at 1, negative 3, for example. So I would have gone 1, 3. There's my vertex. Focus 1, 1, 2, 3, negative 3. Now my parabola is pointing down. So my vertex is still the same. It's still an x squared, but now it's a negative p. The value for p would have also changed here. 1, 2, 3, 4, 5, 6. P would be 6. So then it would have been x minus 1 squared equals 4 times a negative 6, y minus 3. And that would have been my equation. Let's also say it had asked for the directrix. I would have gone up 1, 2, 3, 4, 5, 6, plotted a point, and my directrix would be y equals, we started at 3, we went up 6 points, so it would be y equals 9. Okay, now let's look at example 6. This says find the vertex, the focus, and the directrix of the parabola. So if you notice, this is not in standard form. I need this to be in standard form, which means I'm going to have to complete the square on the x, unless it was already a perfect square, but this is not. So the first thing that I want to do is get rid of my 1/2s, because I don't want to deal with fractions. And I want to get rid of the negative. So I'm going to multiply everything by a negative 2. Has to go across to the other side of the equal sign. So this becomes negative 2y equals x squared plus 2x minus 1. So I multiplied every single term here by negative 2. Now, if that last term was positive, this would have been a perfect square, but it's not, which means I have to complete the square on the x. So the first thing I'm going to do is bump the 1 to the other side. And now I've got to fill that space. So I'm going to take the 2, divide it by 2, that's 1, square it, that's 1. I add it here, and I also add it here. So negative 2y plus 2 equals, factor this, square root of x squared, square root of 1, sign from the middle term, in parentheses and squared. So now I've got the squared part right. If you remember, it said x, it would have been x minus h squared equals 4py minus k. So this side matches this side. You can invert it if you want. I can switch the sides. X plus 1 squared equals negative 2y plus 2. But if you look at the right side, there's nothing attached to this y. Everything's outside the parentheses, which means whatever is here, I need to take out of those terms. So I'm going to say x plus 1 squared would equal, take negative 2 out, which is dividing it by this one and this one. And I get negative 2 times y minus 1. So now I've got it in standard form. And here's the information I know immediately. X is squared, which means it's going to go up or down. And 4p is negative, which means this is going to be a parabola that points down. Second piece of information I can take from it is the vertex. So I already know vertex is negative 1, 1, and it's going to point down. So I've got the vertex. Now I need the focus and the directrix. So if negative 2 equals 4p, and I need to solve for p, I'm going to divide both sides by 4. And I get p equals negative 1/2. So there's how I know it's negative, which means it's going to point down. And the distance from the vertex to the directrix, or the vertex to the focus, is negative 1/2, or is 1/2. So I'm going to go to my equation, which, remember, this point was negative 1, 1, this graph. And I'm going to go up 1/2, and that's going to be my directrix, which means my y, I added 1/2 to it, which means this is y equals 1 1/2, or y equals 3/2. And then my focus is going to be 1/2 less than that. So I'm going to take that 1 and subtract 1/2 from it. This one's a point, so it gets the negative 1. 1 minus 1/2 is 1/2. And those are the two other pieces of information I wanted to know. Directrix and the focus. So this probably is the trickiest because you have to get it into standard form first, and then you've got to figure out your p from your equation. So the first thing I do once I get it into standard form, which is that complete the square part, is look to see which term is squared and what's the sign on the 4p. That tells you what direction you're facing. And then for me, I want to graph it. I'd graph it and then find that p value, add to one side, subtract from the other, whether you're moving right or left or right. Okay, we're going to do one more example like that last one because I think it's the most difficult. So this says find the vertex, directrix, and the focus. It's similar to the last question where it gives you the equation, and you've got to put it in a standard form, and then you've got to find all the information from it. So the first thing I would notice is that I have a y squared this time, which means it's going to be pointing up or down, and I want to solve, or sorry, pointing left or right. And I want to solve for that y squared, so I want to complete the square for the y squared. So I'm going to do y squared minus 8y. I'm going to leave my space. I'm going to bump the 4x to the other side. Now the variable usually comes first, so I'm going to make it negative 4x minus 12. Now I want to complete this square on the y. So take that 8, divide it by 2, and square it. I get 4 squared, which is 16. I'm going to add it here and also add it here. So now I get y squared minus 8y plus 16 equals negative 4x plus 4. So the goal there was to make it a perfect square on the left-hand side, which we did. Now I want to factor it. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses and square it. And now I've got negative 4x plus 4. So I'm super close to my standard form, which is y minus k squared equals 4p times x minus h. But there's nothing attached to this x, so I got to take the negative 4 out. So I get y minus 4 squared equals negative 4 x minus 1. I took the negative 4 off here and also from here. So now I've got my equation. I know it's a y squared, which means it's going to point right or left, but the negative p tells me this is going to be pointing left. So my vertex is 1, 4. And then my 4p is negative 4. So if 4p equals negative 4, then p equals negative 1. This tells me that from my vertex, which is 1, 4, I'm going to the left one for the focus and to the right one for the directrix. So it's going to point this way. My focus 1 left means my focus. I would subtract 1 from my x, which makes it 0, 4. And 1 right for the directrix means I'm adding 1 to the x, which makes it positive 2. And it's a vertical line, so this is an x equals 2. Okay, I know there's one kind of just like this in the homework, so make sure you practice it. And remember, you can always do extra versions. So your goal for this is to complete the 9-1 homework by Wednesday at 8 a.m. You're going to submit the notes from today in their entirety, so make sure they're complete. I should say completed. And then work on the homework that's on WebAssign. Now, I know that there's a lot of graphs here, so if you're getting frustrated on the WebAssign graphs, if you can figure it out, fantastic. It will actually grade your graphs. If you're getting frustrated, you can always graph on Notability. I can't stress enough the importance of showing your work for all this stuff. And then remember that we're going to take a quiz on Thursday for the last sections in 8 that we didn't assess on yet, which is 8-4 to 8-6. And then we'll probably do some sort of assessment on the chapter 9-1 the week after next. All right. Have a great day, guys. Again, remember to stay safe and contact me with any questions. So if you want to comment on your submission, you might need me to go over. I will this week, because we're doing the quiz on Thursday, I'll post a video going over those questions. So just let me know what you need help with. Either comment right in the submission box on your homework, or if you want to go into WebAssign after 8 a.m. on Wednesday, check your answers, see if you understand it, and then comment on that. That would be great too. Have a great day, guys.